Here h is variable. Note this, limit h tends to 0 means h is variable. Therefore m e to the power mx into limit mh tends to 0, h tends to 0. Therefore if we multiply that by a constant m, that will also be very small. This is the other method of finding the derivative of such function or function form without using definition. Before finding derivatives of given functions with the help of fundamental theorems or fundamental laws, we find derivatives of some standard functions using definition. First of all, e to the power mx, we have to follow similar steps. Let y equal to fx equal to e to the power mx. Therefore, f of x plus h equal to e to the power m x plus h. Therefore, f of x plus h minus fx will be equal to e to the power mx plus mh minus e to the power mx. Now this can be written as e to the power mx into e to the power mh minus e to the power mx. Here e to the power mx is common factor, therefore it will be e to the power mx within brackets e to the power mh minus 1. Therefore, from definition, f dash x is equal to limit h tends to 0 f of x plus h minus fx by h. First of all, we have to write the original form, then I put the value. Limit h tends to 0. Numerator is this one, e to the power mx within brackets e to the power mh minus 1. Now this part e to the power mx is independent of h, therefore e to the power mx is taken outside into limit h tends to 0 e to the power mh e to the power mh minus 1 by h. But standard limit is that limit h tends to 0 e to the power h minus 1 divided by h. Here in place of h it is mh. Therefore, to make standard limit we multiply it the denominator by m, and for balancing this one. Therefore, this is equal to m. M is constant, Here h is variable. Note this, limit h tends to 0 means h is variable. Therefore m e to the power mx into limit mh tends to 0, h tends to 0. Therefore if we multiply that by a constant m, that will also be very small. Therefore limit mh tends to 0 e to the power mh minus 1 by mh. This is standard limit. Therefore value of this one is 1. Therefore finally what we get, m e to the power mx. Therefore finally we write ddx of e to the power mx is equal to m into e to the power mx. Now I shall calculate the derivative of cos mx. For sin mx, you have to deduce yourself. Earlier I have found the derivative of sin x and you have to follow the similar method. Already I mentioned mechanical way. Now I am going to find this one, not this one. And you deduce yourself. I am writing here the result. ddx sin mx will be equal to m cos mx. Now let me deduce that one. I keep the format same, will be equal to cos mx cos of m x plus h. Therefore this will be cos mx plus mh minus cos mx. Now this is cos of alpha plus beta form. That means that can be written as cos alpha cos beta minus sin alpha sin beta. Move to the left, or I apply here cos c minus cos d formula. 2 sin mx plus mh plus mx divided by 2 into sin mx plus mh minus mx by 2, and there will be a minus sign. Actually cos c minus cos d equal to minus 2 sin c plus d by 2 into sin c minus d by 2. Therefore I have taken minus here. Now I apply this one from definition. This one we put the value. All divided by h. I take this minus outside, then limit h tends to 0, sin mx plus mh by 2 into limit h tends to 0, sin mh by 2, and this h and this 2, here we find angle is mh by 2. To make that angle at the denominator, we multiply it by m, and for balancing m. Now this result will be, finally we have to put here h equal to 0, therefore minus sin mx into this m, and this is standard limit. Here we can write mh by 2 tends to 0 into 1. Therefore finally this one is minus m sin mx. Therefore t dx cos mx is equal to minus m sin mx. I have deduced by using definition derivative of cos mx. Similarly, we can find the derivatives of, I have mentioned here etc. We can find the derivatives of tan mx as well as cosec mx, then sec mx, these trigonometrical functions. I shall now write a list, write down a list for useful purpose. Also, students, you write yourself the results. Also, we can say summarization. Therefore, number 1, ddx of e to the power mx is equal to m e to the power mx. Number 2, ddx of sin mx is equal to m cos mx. Number 3, ddx of cos mx minus m sin mx. Number 4, ddx of tan mx m 6 square mx. Number 5, ddx of cosec mx, that will be equal to minus sec mx. Number 6, ddx of sec cosec mx, cot mx, sec mx, that will be equal to m sec mx tan mx. Then number 7, ddx of cot mx that is equal to minus m cosec square mx. Also ddx of say log mx, that will be equal to m into 1 by 1 by x. Next, we shall discuss the derivatives of. I have discussed how to find the derivative of these functions. Actually, derivatives of these functions also can be determined with the help of a rule which will be discussed in detail later. Just I give the idea, these functions can be stated as, I take this one sin mx. Sin mx, we see the angle is mx, not x. We say that such functions as function of function. That means f of say phi x. That means phi x is equal to mx. Then we have the formula taking phi x equal to u, we can write ddx of fu, and that is equal to ddu fu into du dx. ddx of this one, where u equal to phi x, will be equal to ddu. Since it is function of u, therefore we cannot differentiate it with respect to x directly. We use this one, ddu of fu into du dx, and this one is called chain. It will be discussed later in detail. Therefore, in this case, it will be f dash u into du dx. That means we differentiate it with respect to this one, taking this one as mx, and that is to be multiplied by ddx of u. That means ddx of sin mx is equal to ddx of sine u. Rather, ddu into du dx, that means cos u into ddx of mx. Finally, it is cos mx into m. We take this m in front, m cos mx. Therefore, ddx of sin mx is equal to m cos mx. This is actually chain rule. Applying chain rule, we get this one. And try to remember like this: ddx of fu is equal to ddu of fu into du dx. This is called chain rule, and finally we get this one. This is the other method of finding the derivative of such function of function form without using definition. Now I am going to find out derivatives using fundamental theorems. I will work out some now. I take few sums. I have taken three sums. First of all, fx equal to 1 plus x whole cube divided by x, that is quotient form. Second one, y equal to this one, also quotient form, and third one is also of quotient form. First, in such cases, if we find the given function is of quotient form, then first we simplify. If possible, we simplify. Then apply fundamental theorems. Here we find fx can be written as 1 plus x whole cube, that means we can apply the identity after expanding 1 plus x whole cube. I have divided the whole by x and get this one. The simplified form is this one. Therefore, differentiating with respect to x. With respect to x, that is denoted by this short symbol w for with, r for respect, t for to, with respect to x. Better you mention this one before taking the derivative of fx. Then left hand side will be f dash x, and this one will be ddx of x square plus 3x plus 3 plus x to the power minus 1. Now I apply fundamental theorem. ddx of u plus v, that is equal to du dx plus dv dx. We can apply that for more than two functions also. Say u plus v plus w plus dot 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 like this. Then that will be equal to du dx plus dv dx plus dw dx plus dot dot dot. Here I apply this one. ddx of x square plus ddx of 3x plus ddx of 3 plus ddx of x to the power minus 1. This is ddx of x to the power n form, that is n x to the power n minus 1. This will be 2x. Now 3 is constant, that is taken outside, into derivative of x, that is 1. Derivative of constant 0. This is of the form x to the power n, therefore it will be minus 1 x to the power minus 2. Therefore f dash x equal to 2x plus 3 minus 1 by x square. When you get given function as quotient form, if it is possible, you simplify before getting the derivative. Here I have simplified this one, then I have differentiated both sides. Then number 2. It is also of the quotient form. Now let us see whether this one can be simplified. First we note the numerator, x to the power 4 minus 4x cube plus 3. This can be resolved into factors. We first factorize that. Already you have learned in the lower classes, that is 8, 9, 10 classes, how to factorize the given expression. Here you can apply the vanishing method also. I have arranged the expression like this and factorize. This is of the form a cube minus b cube. Therefore, the factor form will be now x minus 1 is the common factor. Rid of this part. Therefore, y is equal to, numerator is x minus 1 within brackets x cube minus 3x square minus 3x minus 3 divided by 3 into x minus 1. Here x minus 1 will be cancelled, and remember to mention that x is not equal to 1. If x be 1, then the matter will be division by 0, which is undefined. Therefore, we mention here x is not equal to 1. Therefore, y equal to 1 by 3 within brackets x cube minus 3x square minus 3x minus 3. Therefore, dy dx of the whole x cube minus 3x square minus 3x minus 3 divided by 3. 3 is constant, therefore it is taken outside, into dx of the whole numerator. Now we apply the fundamental theorem. Ddx x cube minus ddx 3x square minus ddx 3x minus ddx 3. When we learn, then we write these steps in the initial stage, but when you will be skilled enough, you can skip this step. Initially, we write this to understand the application of fundamental theorems of differentiation, but later we shall skip this result, and this will be equal to 1/3 x cube derivative means 3x square minus 3 into derivative of x square 2x minus 3 into derivative of x is 1 and minus 0. Derivative of x cube form ddx of x to the power n, that is n x to the power n minus 1, 3 into power 3, that means that will be 3 minus 1, that is 2. Then ddx of constant into x square, constant is taken outside as per the theorem ddx of c fx equal to c into derivative of fx, etc. Then on simplification we get x square minus 2x minus 1. Therefore, derivative of this one is x square minus 2x minus 1. Remember one thing, if the given function be of quotient form, then if possible you simplify the given function, then find the derivative. Thus I have got the derivative of this function. Then the last one, number 3, y is equal to cos x minus cos 2x divided by 1 minus cos x. Here we find trigonometrical function. Now in this case also, you first think whether that can be simplified. Numerator is cos x minus cos 2x. Now if I put the cosine form of cos 2x, then that can be simplified. I put that first. Cos x minus cos 2x, cosine form is 2 cos square x minus 1 divided by 1 minus cos x. That means cos x plus 1 minus 2 cos square x by 1 minus cos x. We multiply both numerator and denominator by minus 1, then numerator will be 2 cos square x minus cos x minus 1 cos x minus 1. Now the numerator can be resolved into factors. I show that on the right side. 2 cos square x minus cos x minus 1, 2 cos square x minus 2 cos x plus cos x minus 1, 2 cos x is common factor, cos x minus 1 2 cos square x minus cos x minus 1 can be written as the product of these two factors. Therefore, y is equal to cos x minus 1 into 2 cos x plus 1 cos x minus 1. Therefore, this is 2 cos x plus 1. Differentiating both sides with respect to x, dy dx equal to d dx 2 cos x plus 1. Now apply fundamental theorem. D dx 2 cos x plus d dx 1. Now 2 is constant, therefore 2 into d dx cos x, 1 is constant, therefore derivative is 0. Therefore dy dx is equal to minus 2 sin x. This is the answer. Now applying fundamental theorems, I have found the derivatives of these three functions. In the later part, I shall work out few more sums.